basically what I want to do is give you 3 use cases from my research and services at 3 pretty amazing companies. Actually, I'll cover how those all fit together, and then we'll be shifting back to Professor Jane, and we'll take questions. So one of the things that I want to do for you first, it kind of follows along with what the others have said, is let's take a look at what business research and services, what those folks are trying to focus on. And then we'll take a quick look at an introductory use case, and then I want to go into the 3 different experiences at Amex and Intel and eBay that I've had in my own research. So first off, there's 10 basic priorities that I'm going to run through really quick that the business folks or the business end they're working on very hard. First of all, how do you grow services? We have a lot of companies out there that are knee-deep into products, and they're not sure how they're going to deal with the services. That's where the growth is. So for example, you take a John Deere tractor, they're considering how to put a Qualcomm chip inside that tractor so that out on the field it can phone home and say how it's operating and maybe get instructions back from home to say how to maximize the way that the pistons are working or whatever. So companies are trying to come up with, if they're product oriented right now, how do they shift to more service orientation? Next thing we see is a big growth area for services in transformative or types of well-being that people are going to focus on. So where the dollars are going to be made is in our more leisure society, and what can we do to facilitate it? The third one is creating and maintaining a service culture. So I'm sure you've all had bad service experiences. How do you get the employees to all deliver or be consistent about the service that you want to deliver? The next thing they're working on is stimulating service innovation. So how do we get service success? And ironically, they're starting to bring in a lot more of the arts and media into that environment to help improve how we get services. So Disney, you think of a very big services company, and how will that leverage into other types of activities that we associate with services? Enhancing service design is a huge problem. A lot of us tend to think of, well, why don't you just lay out the business processes for the service? But it turns out in services we want high variance. When you go to the doctor and you're sick, you want them to take the extra time if they need to take it. You can't drive all the variance out. So service is very unique. They use service blueprinting to design the services, and it's much different than our business process approach. The next one is how do you optimize service networks and value chains? And this is probably the least studied in the business area. If you have business-to-business networks that are trying to provide service, linked together to give a customer service, how do you keep them tied together and integrated? And there's lots of legalities, and I'll get into that in just a little bit. The next one is how do you brand services? So right now in your own mind, what service do you know that has a great brand? What comes up real quick? See? Okay, Google, service, right? Ritz-Carlton comes to them. So they're trying to figure out how more things can be branded as service. We're quick to say Kleenex or Procter & Gamble or whatever, but branding services is going to be a key. Then how do you enhance the experience of services through co-creation? So Nike has experimented with having the people who actually run help design the next version of the shoe, right? So how do you engage customers in building the next product or service that you're trying to deliver? Last here, or 9, almost the last, is how do you measure the ROI of this? So there's still not good mechanisms out there. Businesses are trying to grapple with it, and it's good for you to know that that's where things are at. The last one is the technology priority, and I think that this fits us the most. How do we leverage technology to advance service? And one of the most important things here is that the mobility has really changed the transaction. So our transactions can now be done anywhere that we want, whenever, however we want to make them. And that totally messes with the business folks and how they set prices. Because now you can set prices based upon somebody really needs gas because they ran out, and it's a little scary, but that's where services are shifting. So now for just a quick little example to drive home a couple of points that I'm going to make about the use cases coming up. This is a picture of all around the world the different Starbucks experiences. So you think in your mind now, what's your favorite Starbucks drink? I know, foofy, latte. You come up with all those words, right? Well, what's interesting is those words are common vocabulary all around the world, right? And you see them on these receipts. The upper left one, by the way, is from New York with about 12 shots added to it, so that's why the New York Minute goes so fast. So, Starbucks is smart like a fox. They're teaching us basically a business action language, and they have some reasons for it. Now, we're delighted because we feel like it's a customized experience when we walk into Starbucks and they say, oh, you want your coffee this way. Well, they make it exactly the way we want it because we know how to order it. But what happens if you don't order it right? You get taught. You get told how to order it. So Starbucks has created a business action language associated with their business service delivery, and that has some important implications. First of all their business processes get streamlined around this language. All their computing systems can be scaled and built around the common language and the common verbiage that we're used to seeing. The customized service, of course, is very time-consuming, and that's what they pride themselves on. But it turns out by having us learn how to order, the queue is reduced significantly, so they can speed us through the line while we're still smiling and very happy. But behind the scenes, they get a whole lot of advantages underneath from the fact that they've created a common business language. So now let me shift to first use case, American Express. American Express had built a component. They have a travel portion to their company and a charge portion to their company. They created, they're very advanced in SOA and services computing, and they created a new service that combined the two data warehouses and accomplished something called Zap the Gap. Now what Zap the Gap did is it would look at people who charged their travel, coach, but then when they got to the airport, they'd upgrade to first class, right? Sneaky little guys. Well, what Amex was doing was catching those people that did that in violation of their corporate policy and reporting that or giving that report free to the companies who were using their card. So they leveraged information as a service to extend their network and provide more capabilities. Turns out that once they built that component, it opened a Pandora's box of other components that they thought they could build that did similar things, and their whole business intelligence group got bottlenecked trying to build those things out. Turns out when you go to American Express, there's 7 people there you meet. 4 of them don't even work for American Express. They're outsourced to different groups. So what we had to do was figure out in our project, how do we link these groups up and give them a way to help manage when these components that are hot, or these systems that are hot, services that are hot, get really going and being built. How do you get them all together on the same page? Guess what? The answer was to create a common semantic. And I'm not going to go through all the details of it, but we had to do service modeling. So we had to lay out a service model, work with all of them to build a service model, and it's just a very critical way to integrate the business and the services science community and computing community is through modeling. We need more work in that area. Just a little bit more on this. We had to create an action language. We named it DISCO. So we thought of every service entity, something catchy, right? Something that you wouldn't forget, but that took you out of your normal vocabulary. Discover, instantiate, score, choreograph, orchestrate, and bang is measure performance. So that's what those stood for. We took them out of their comfort zone, changed everybody to a common semantic, and you can see on the right there the savings amounted to about 35% for their recent projects because they could more accurately size things. Showed Intel that work. And they had some folks there working in the supply chain, and they said, we have this trouble with the Dell folks. I hope nobody's here from these companies. They'll beat me up later. But this was old, right? So the Dell folks would get complaints about the computers in there saying, oh, it's that darn Intel chip, right? So they couldn't figure out a way to get completely across the value chain to get to the customer side of what they were hearing, and so they decided to take a complete services approach to reevaluate their value chain. They had some other things that they were interested in. Virtualization and VMware, those types of products were taking off. And so think about what impact those might have on chip sales. So they were kind of curious about how virtualization was going to work into the whole services space. So our main interest, our charge was to say, look, suppose we want to outsource business processes on the fly, dynamically. How do we orchestrate that throughout our supply network from your services computing perspective? So go to work on that, guys, and come back with something about that. So they had some ways that they were going about it, but they wanted to create a standard, and our job was to do R&D to help them with that standard. So let me just show you a couple of quick examples. This is a very abstract model, but if you look at each of these entities, you can consider it as an organization. The business processes translate down to SOA and then translate down to what they called SOI, service-oriented infrastructure. if you knew the prior execution needs in SOI of a particular business process, why not remember that, leverage that in the next time that you need to execute that business process, and use that information to source from the cloud the types of compute resources that you might need. So that was the design behind this model. So this depicts that multiple organizations are involved. Business processes are being outsourced throughout the organizations, but inside each company, they're also outsourcing at the SOA layer and outsourcing at the SOI layer. What a mess. How do you keep track of all this? Governance is going to be interesting as we watch this unfold. They had to consider workload mapping between the layers. So if you want to talk to a cloud provider and ask for a certain amount of infrastructure need, you don't know what's inside that cloud provider's capabilities. You don't know the details. So semantics became the answer. So our approach was to think of business action languages, so to speak, and how semantics could help collaborate between these layers. So the top layer there is a virtual corporation. How do you translate to what your needs are in SOA, and then from there, what do you need in SOI to be able to execute? So for the workload mapping, we provided basically analytical models of prior executions of the major business processes, kept those in a data warehouse, and were able then to leverage those. But the key was the semantics. And we borrowed some from some researchers who worked in this area, and this is an example of a semantic. There could be many more, but you can see this talks about the hardware specifics, clusters, hard disks, memory, all those types of things. But what's kind of interesting is that you can start to build for a particular service execution Boolean statements of the amount of execute performance that you're going to need to be able to send to a cloud provider. So a lot more work is needed in this area, but you can see semantics mapped up and down the whole business process to SOA to SOI as a potential solution to this. Third case, eBay. Totally shift here. In case you've used eBay lately, you might not know it, but everybody that's going into eBay is pretty much involved in an experiment. So the way that eBay has decided to innovate their services is everybody coming in is some kind of an experiment with how they're modeling the interface or changing things in and out to see how effective that service innovation might be. If you want to do thousands and thousands of experiments, you can't just have your same old infrastructure. You have to come up with a new way to do it. They decided to do kind of a multi-tenant model with their data warehouse, and they lease out basically to the different business units the capability to do experiments with business intelligence. So that virtualized data warehouse is there. They call it sandbox experimentation that you can do. And the example business wins that they had initially is that they now know the actual revenue per minute per day by day of week for each keyword that they have. In the first year of discovering that, they paid for the whole infrastructure investments. So just on an AdWord capability of savings. They also developed things like the fashion graphic system. Now, I don't use this, but evidently if you go to a picture there and you see a piece of clothing that you like being modeled, they can actually graphically match other elements that are on eBay to that type of clothing and make recommendations, of course, that would fit your needs. These were all experimented with. Those are the business value that they found from those different capabilities. Question for them was, they asked, how do we measure ROI and what does it mean? So I think this was really an interesting one. First of all, you can get on the top A graph here, if you could go with the multi-tenant model, right, a services computing approach, you can reduce your infrastructure cost. But on the business side of this, what they found was that if they can do more experiments, make them more effective in self-service, then they can increase the marginal return on each experiment. So the sweet spot for services computing here was to support this on both ends, and it was a huge win for them to implement it. So some of the eBay lessons here real quick. I think this thing is going to go outside the firewall, right? All the people that list their items on eBay, now they're going to want to do their own experiments, right? That's huge. That's really fun for us as researchers because there's a lot of things that we can look at in that area. Master data management in the BI space, most folks kind of think that's beneath them as an area of study, but that's going to be huge because that's the common semantics that businesses are deploying. And services computing with BI and data mining is, to me, the biggest growth area. My current work is back again with Intel, and it involves the AIM suite. The AIM suite is visual signage, digital signage, that can detect who's looking at a video, not personally, right? It's anonymous. They can see how long you watch the video, and they can track that and provide it inside the retail stores to help support another type of service, better service, right? So here we're finding that the legal contract provisions between the service providers are a nightmare, but it would be nice if we had services computing research that thought about how these legal requirements manifested or could be modeled directly into the contracts at the services computing level. Next thing is the predictive analytics approach are a lot different than what we're accustomed to deal with, because a predictive model might give a lift of sales inside the store. How do we charge for that? How do we bill for that? How do we think of a predictive model from a services computing standpoint? It's a pretty exciting area. So that kind of, we'll have some more on this in the afternoon panel on services economics. So the lessons learned. Try to tie what you're doing in services computing with the business research directions, because they're going to have the money to pay if you could do that. If you can think of the business action languages and align them with how you're approaching the services computing approaches, that's going to be a big win too. And I think it's one that's very much underexplored, the translations of those semantics. Service modeling is going to go a long way, I think, in bridging the two areas. And I've seen some great papers come across in these conferences. But I think we need to somehow get to a point where we've got some standardization, like a UML or something, of services computing that we could leverage. The last one is these B2B business relationships and capabilities are a key domain, and it's messy. Don't underestimate what the business is willing to save for you. If you need to get things out of a data warehouse, leverage them to make your services computing better. That was one of the shocks from the Intel side, is just start assuming that those analytics are there and available for you to begin to use in your solutions. Service semantics need a lot of research. There's a lot of different service semantics out there. I don't know if they can be mapped directly to different business languages, or if there's some intermediary translation that can come about that would enable that. Analytics as a service is the next frontier. This is not we have a saying, it's not your father's Ford or Chevy. Analytics as a service is not your father's services computing approach. This one's really different because business is very, very keen on how to protect those assets, especially since they're intellectual. Thank you.
Wow.